Imagine waking up one morning to discover that you exist in two places at once, not metaphorically, but literally. Through a groundbreaking consciousness uploading experiment, your entire mind, memories, thoughts, personality, everything that makes you you, has been perfectly replicated into a quantum computer, while your biological brain continues to function normally. As you lay in the laboratory's recovery room, you can simultaneously experience existence through your original body and through the digital interface. Both versions of you feel equally authentic, equally real. But here's where things take a mind-bending turn. The digital version of you begins making different choices, forming new memories, and developing distinct perspectives. Within hours, despite starting as perfect copies, you begin to diverge into two increasingly different versions of the same person. Now comes the devastating question that will shatter your understanding of identity. If these two conscious experiences are diverging, which one is really you? This scenario forces us to confront one of the most profound paradoxes of consciousness and identity. The traditional notion that we each have a single, continuous self crumbles when faced with the possibility of perfect replication. We instinctively want to claim that the original biological brain must be the real you. But this raises troubling questions. If the digital copy contains exactly the same memories, personalities, and thought patterns at the moment of creation, what makes it any less authentic? The biological you might protest that you have the original neurons, the original matter. But isn't consciousness more about the pattern of information rather than the specific particles carrying it? The paradox deepens when we consider that our biological brains are constantly changing anyway. The neurons in your brain today are not the same ones you had 7 years ago, as cells die and are replaced. Yet we consider ourselves the same person throughout this gradual replacement. So, if the specific physical matter isn't what makes you you, then how can we dismiss the digital copy as less real? Both versions began with identical patterns of consciousness. This isn't just a thought experiment about some distant future technology. It cuts to the heart of questions that have puzzled philosophers for millennia. What makes you the same person from moment to moment? Is consciousness tied to specific physical matter, or is it more about patterns of information? If your consciousness could be perfectly copied, would both versions have equal claim to being you? And what happens to our notion of individual identity when the possibility of multiple diverging versions of ourselves becomes real? As we dive deeper into this paradox, and others like it, we'll explore how these seemingly abstract philosophical puzzles have profound implications for our understanding of reality, consciousness, and what it means to be human. We'll examine how different versions of these paradoxes appear throughout science, philosophy, and even everyday life, challenging our most basic assumptions about existence. The consciousness upload paradox is just the beginning. Over the next few hours, we'll encounter increasingly mind-bending scenarios that will force you to question everything you think you know about reality, time, identity, and truth itself. From quantum immortality to the simulation hypothesis, from the paradox of infinite choices to the impossibility of perfect prediction, each new puzzle will push the boundaries of your understanding and leave you questioning the very nature of existence. Prepare to have your mind thoroughly transformed as we embark on this journey through the most perplexing paradoxes ever conceived by human minds. These aren't just intellectual exercises, they're gateways to understanding the deepest mysteries of consciousness, reality, and our place in the universe. Following our mind-bending opening about the consciousness upload paradox, let's explore the fundamental nature of what makes these paradoxes so disturbing to our understanding of reality. Consider for a moment the alarming implications of what quantum physics tells us about observation and reality. Scientists at the prestigious Maxwell Chen Institute recently conducted an experiment that seems to suggest something impossible. The mere act of measuring a quantum particle appears to affect its past. In their groundbreaking study, they used a series of entangled photons to demonstrate that observing a particle's state now could seemingly influence its behavior before the measurement was even made. This leads us to an even more troubling realization about the nature of reality itself. If observation can influence the past state of a particle, what does this mean for our understanding of cause and effect? The classical view that events proceed in a neat, linear fashion from past to future begins to break down at the quantum level. But here's where it gets truly mind-bending. We're not just talking about subatomic particles anymore. These quantum effects can be scaled up to affect larger systems through a process called quantum amplification. Imagine a sealed box containing a sophisticated quantum detection device connected to a vial of poison. The device is designed to trigger based on the quantum state of a single particle. According to quantum mechanics, until the box is opened and the system is observed, the particle exists in multiple states simultaneously, and therefore, paradoxically, the poison must be both released and not released at the same time. This isn't just theoretical physics. Similar experiments have been conducted using increasingly large quantum systems, pushing the boundaries of where quantum effects end and classical physics begins. The implications become even more staggering when we consider consciousness itself. If quantum effects can influence macroscopic systems, and consciousness is ultimately based on quantum processes in our brains, as some theoretical physicists suggest, then we're faced with an unsettling possibility. Our very awareness might be creating the reality we perceive. This isn't mere philosophy. It's supported by increasingly sophisticated experiments in quantum mechanics that show particles don't seem to have definite properties until they're measured. The renowned physicist Dr. Sophia Nakamura at the Institute for Advanced Reality Studies puts it this way: we're not just observing reality, we're participating in its creation. Every measurement, every observation, every conscious moment might be collapsing infinite possibilities into concrete reality. This suggests something profound about the nature of existence itself, that consciousness and reality might be fundamentally inseparable. But this creates an even deeper paradox. If consciousness affects reality, and reality gives rise to consciousness, we're caught in an infinite loop of causation. Which came first? How can consciousness emerge from a reality that requires consciousness to exist in the first place? This chicken and egg scenario becomes even more complex when we consider the role of time itself. Recent experiments at the Quantum Dynamics Laboratory in Geneva have shown that quantum particles can become entangled across time as well as space. This means that particles can show correlations not just with other particles existing now, but with particles in the future or past. The implication is staggering. Time itself might not be the linear progression we experience, but rather a complex web of interconnected moments, all influencing each other across what we perceive as past, present, and future. This fundamental interconnectedness of reality challenges our most basic assumptions about cause and effect, free will, and the nature of consciousness itself. If every moment is connected to every other moment through quantum entanglement, then the very idea of individual choice or free will becomes questionable. Are our decisions truly our own, or are they part of an intricate web of quantum correlations stretching across time and space? As we delve deeper into these paradoxes, we'll see how they connect to even more mind-bending implications about the nature of existence, consciousness, and reality itself. The quantum nature of reality suggests that everything we think we know about causation, time, and consciousness might be fundamentally flawed, and the truth might be far stranger than we ever imagined. These insights form the foundation for understanding the even more bizarre paradoxes we'll encounter as we continue our journey through the most mind-bending concepts in modern physics and philosophy. Each new paradox will build upon these fundamental uncertainties about the nature of reality, pushing our understanding to its limits and beyond. Following our exploration of quantum reality and consciousness, let's delve into perhaps the most unsettling paradox of personal identity. What happens when you try to rebuild a person piece by piece? Picture this. In a state-of-the-art research facility in Vancouver, scientists have developed a revolutionary technology called neural templating. This process can scan and record the exact neural pattern of any brain region with perfect accuracy, then replicate it in synthetic neural tissue. Dr. Elena Rossi, the lead researcher, proposes a thought experiment that has haunted philosophers and neuroscientists ever since. Preparing and narrating this theory took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the theory. Imagine starting with a living, conscious person. Let's call her Sarah. The scientists begin by replacing a tiny cluster of neurons in Sarah's brain, perhaps just a few hundred cells, with synthetically grown replacements that perfectly match the original neural patterns. Sarah remains conscious throughout the procedure and reports feeling completely normal. Her memories, personality, and sense of self remain unchanged. After all, our brains naturally replace neurons throughout our lives without disrupting our identity. But here's where it gets disturbing. The scientists continue the process, gradually replacing larger and larger portions of Sarah's brain with synthetic copies. 10%, 20%, 50%. At each stage, Sarah maintains perfect continuity of consciousness and identity. She feels like exactly the same person, with all her memories and personality traits intact. But when they reach the point where 99.9% of her original brain has been replaced with synthetic tissue, a profound question emerges. Is this still Sarah? The immediate response might be, of course it's still Sarah. She has the same memories, personality, and continuous stream of consciousness. But then, the scientists reveal their true mind-bending twist. They've preserved all of Sarah's original neurons. Using advanced biotechnology, they begin reconstructing a new brain using these original cells, arranging them in exactly the same pattern as they were in Sarah's original brain. When this process is complete, there are now two identical brains, one made of synthetic tissue that Sarah's consciousness currently inhabits, and one reconstructed from her original biological neurons. This creates an impossible paradox of identity. The synthetic brain has the continuous stream of consciousness, maintaining Sarah's experience of being herself throughout the gradual replacement process. But the reconstructed biological brain contains all the original physical material that made up Sarah's original identity. If consciousness is tied to physical matter, wouldn't the reconstructed biological brain have the stronger claim to being really Sarah? Yet how can we dismiss the continuous conscious experience of the synthetic brain? The paradox deepens further when we consider the role of memory and conscious experience. During the time it took to reconstruct the biological brain, the synthetic Sarah has been living her life, forming new memories and experiences. The reconstructed biological brain, if activated, would wake up with only the memories up to the point when the replacement process began. So now we have two diverging versions of Sarah, one with continuous consciousness but synthetic neurons, and one with original neurons but outdated memories. Dr. Rossi's team has discovered that this paradox becomes even more complex when we consider the nature of consciousness itself. Recent studies at their facility suggest that consciousness might not be localized to specific neurons at all, but rather emerges from the patterns of information flow across neural networks. This raises the possibility that both versions of Sarah could be equally real, that consciousness might be more about the pattern than the physical substrate. The implications extend far beyond just personal identity. This paradox forces us to confront fundamental questions about what makes us who we are. Is identity tied to physical continuity, conscious experience, or the pattern of information that makes up our memories and personality? If consciousness can be maintained while gradually replacing every physical component of its substrate, what does this tell us about the relationship between mind and matter? As we continue to explore these paradoxes, we'll see how this question of identity and consciousness connects to even deeper mysteries about the nature of reality and existence itself. The gradual replacement paradox is just the beginning of a journey that will challenge everything we think we know about who and what we really are. This particular paradox also raises profound ethical questions that we'll explore in more detail. If we can create multiple versions of a person, each with legitimate claims to being the real version, what are the moral implications? How do we handle questions of rights, relationships, and responsibilities when identity itself becomes fluid and multiplicative? Building on our exploration of identity and consciousness, let's examine a paradox that challenges our understanding of free will and decision-making in a way that will fundamentally disturb your sense of autonomy. At the prestigious Institute of Advanced Decision Science in Stockholm, researchers have developed a system they call the choice predictor. Using a combination of advanced brain scanning technology, quantum computing, and artificial intelligence, they claim to be able to predict with perfect accuracy what choice a person will make before they make it. Not just simple choices, but complex moral decisions and life-altering judgments. Here's where it becomes truly unsettling. The researchers invite a volunteer, let's call him Marcus, to participate in an experiment. They tell him that the choice predictor has already written down the exact decision he will make in a complex moral dilemma he hasn't heard yet. The prediction is sealed in an envelope. Marcus is confident that whatever choice he makes will be his own free decision, completely independent of what's written in that envelope. The researchers then present Marcus with the dilemma. There are two buttons before him. Pressing the red button will donate $1 million to save children's lives, but it will also cause moderate pain to an innocent person. Pressing the blue button will prevent the pain, but withhold the donation. Marcus must choose. He carefully considers both options, weighing the moral implications. He feels the weight of the decision, believes he's carefully reasoning through it, and finally makes his choice. When the envelope is opened, the prediction matches his decision perfectly. This happens again and again with different volunteers and different choices. The success rate is 100%. But here's the mind-bending part. The choice predictor doesn't just predict the final decision, it can also predict the exact thought process that leads to that decision, including all the doubts, considerations, and moral reasoning that the person experiences while making their choice. Dr. Isabella Chen, the lead researcher, explains the devastating implications. If a person's decision can be predicted with perfect accuracy before they make it, including the exact thought process they'll use to reach that decision, was it really a free choice? The very reasoning process that makes us feel like we're making a free decision is itself predictable. This creates a paradox that strikes at the heart of free will. If every thought, every consideration, every moment of moral reasoning that leads to our decisions can be predicted in advance, then how can any decision be truly free? Yet at the same time, each person experiencing these decisions feels absolutely certain they're making free choices based on their own careful reasoning. The paradox becomes even more disturbing when we consider the implications for moral responsibility. If Marcus's entire decision-making process, including his moral reasoning, was predictable in advance, can he be held morally responsible for his choice? Yet if we abandon moral responsibility, the very foundation of human society and ethics begins to crumble. Dr. Chen's team has taken this even further. They've discovered that showing people their predicted choices in advance doesn't change the outcome. The predictions remain accurate even when people actively try to defy them. This suggests something even more unsettling. Our very attempts to assert our free will might themselves be predetermined. Consider the implications for your own life. Every decision you've ever made, every choice you're proud of or regret, every moral judgment you've carefully reasoned through, all of these might have been predictable in advance, including the exact thought process that made you feel like you were making a free choice. The feeling of free will itself might be nothing more than a predictable part of our predetermined decision-making process. This paradox extends beyond individual decisions to challenge our entire conception of human agency and consciousness. If our thoughts and decisions are predictable in advance, what does this mean for consciousness itself? Is our sense of being conscious, autonomous beings, making free choices merely an illusion, a predetermined pattern of thoughts and feelings that creates the sensation of free will without its reality? As we continue to explore these paradoxes, we'll see how this question of free will and determinism connects to even deeper mysteries about the nature of consciousness, time, and reality itself, the choice prediction paradox, forces us to confront the possibility that our most fundamental sense of being free, conscious agents might be built on an illusion. And yet, paradoxically, this illusion might be essential to human existence and morality. Building on our explorations of consciousness, free will, and identity, let's confront perhaps the most disturbing paradox of all, one that challenges the very nature of your current existence and everything you believe about being alive right now. At the Quantum Mortality Research Center in Zurich, Dr. Victor Novak has proposed what he calls the quantum immortality paradox. The premise starts deceptively simple, but leads to an impossible conclusion that will make you question whether you can ever truly die. Consider this. According to quantum mechanics, every possible outcome of an event occurs in different branches of reality. When you flip a coin, one universe sees heads, another sees tails. This is the widely accepted many worlds interpretation of quantum mechanics. Now, apply this to a scenario involving your consciousness and survival. Imagine a perfectly sealed room containing a device that's linked to a quantum event, like the decay of a radioactive particle. If the particle decays, a lethal mechanism activates. If it doesn't decay, nothing happens. According to quantum mechanics, both outcomes must occur in different branches of reality. Here's where it becomes deeply unsettling. From your perspective, as the person in the room, you can only experience the branches where you survive. Dr. Novak explains, in every branch where the lethal mechanism activates, consciousness ceases. But in branches where it doesn't activate, consciousness continues. Since you can only experience branches where your consciousness persists, from your subjective perspective, you will always find yourself in a branch where you somehow survived, no matter how improbable that survival might be. This leads to an impossible conclusion. From your own subjective perspective, you cannot experience death. There will always be some branch of reality, however unlikely, where you survive. Even as you age, even in situations that should be certainly fatal, your consciousness will always find itself in an increasingly improbable branch where you somehow survived. The implications become even more disturbing when we consider the experiences of others. In most branches of reality, other people would observe your death. Your family would mourn. Your affairs would be settled. But your conscious experience would continue in an increasingly isolated branch where you beat the odds. This creates a horrifying possibility. Are we all already living in such branches, having survived countless near-death experiences in other realities? Dr. Novak's team has identified what they call quantum survival markers, statistically impossible coincidences and survivals that might indicate we're already experiencing this effect. They've documented cases of people surviving situations with virtually zero probability of survival, each survival steering them into an increasingly improbable branch of reality. The paradox becomes even more complex when we consider aging. If consciousness always continues in some branch, does this mean there are branches where people live far beyond normal life expectancy? The mathematics suggests that consciousness would find itself in increasingly bizarre and improbable scenarios, always managing to continue despite overwhelming odds against survival. Consider the implications for your own existence right now. How many fatal accidents have you narrowly avoided? How many times have you just happened to avoid a potentially deadly situation. In countless other branches of reality, those events led to your death, but you can only experience the branches where you survived. Your current consciousness might already be threading an increasingly narrow path through probability space, surviving against impossible odds. This raises profound questions about the nature of death and consciousness. If subjective immortality is real, what does this mean for our understanding of mortality? Are we all immortal from our own perspective while appearing mortal to others? The mathematical implications suggest that each consciousness might be eternally threading an ever-narrowing path through probability space, finding increasingly unlikely ways to continue existing. The philosophical implications become even more complex when we consider the relationship between consciousness and physical reality. If consciousness always finds a way to continue, does this suggest that consciousness is more fundamental than physical reality? Are we living in a universe that's structured to ensure the continuity of conscious experience, no matter how improbable that continuity might become? As we delve deeper into these paradoxes, we'll see how this quantum immortality scenario connects to even more profound questions about the nature of existence, consciousness, and reality itself. The possibility that we might all be experiencing an endless series of improbable survivals challenges everything we think we know about life, death, and the fundamental nature of conscious experience. Building on our exploration of quantum immortality, let's delve into an even more disturbing implication about the nature of reality and probability, one that suggests we might be living in the most improbable universe imaginable. At the Center for Existential Probability Research in Berkeley, Dr. Maya Patel has been developing what she calls the improbable reality hypothesis. The basic premise starts with a simple observation. If infinite parallel universes exist, containing every possible variation of reality, then we should statistically expect to find ourselves in one of the more common, average universes. But what if we're not? Consider the parameters that make our universe capable of supporting life. The fundamental constants of physics, things like the strength of gravity, the strong nuclear force, and the cosmological constant, are all balanced on a knife's edge. If any of these constants were even slightly different, atoms couldn't form, stars couldn't burn, and life as we know it couldn't exist. The probability of all these constants having exactly the right values is astronomically small. But here's where it becomes truly mind-bending. Dr. Patel's team has calculated that our universe isn't just improbable. It's far more improbable than it needs to be to support life. They've identified dozens of excessive coincidences, features of our universe that are incredibly unlikely, but aren't strictly necessary for life to exist. Take our moon, for instance. It's exactly the right size and distance to appear the same size as the sun from Earth's surface, creating perfect solar eclipses. This cosmic coincidence serves no necessary function for life, yet it's incredibly improbable. The same goes for the mathematical beauty of physical laws, the golden ratio appearing throughout nature, and countless other unnecessary perfections in our universe. Dr. Patel explains the disturbing implication. We appear to be living in one of the most improbable possible universes, far more improbable than necessary for mere existence. This suggests either that our understanding of probability is fundamentally flawed, or that there's something deeply wrong with our assumptions about reality itself. This leads to what she calls the improbability paradox. If infinite parallel universes exist, and we're experiencing one of the most improbable ones, this implies that our consciousness might be somehow attracted to improbable realities. Perhaps consciousness itself has some fundamental relationship with improbability. The implications become even more unsettling when combined with our previous discussion of quantum immortality. What if consciousness not only survives in increasingly improbable branches of reality, but actively seeks out the most improbable possible experiences? This would explain why we find ourselves in a universe that seems unnecessarily perfect in so many ways. Consider the mathematics of your own existence. The probability of your specific genetic combination coming into being is already astronomically small. Add to that every near-death experience you've avoided, every coincidence that led to significant moments in your life, every unlikely event that shaped your current reality. The combined improbability of your current existence is virtually impossible. Yet, here you are, experiencing it. Dr. Patel's team has developed a theoretical framework suggesting that consciousness might act as an improbability magnet, naturally drawing experiential reality toward increasingly unlikely configurations. This could explain why life itself seems to defy entropy, creating more complexity and order rather than dissolving into chaos. The paradox deepens when we consider the role of observation in quantum mechanics. We already know that the act of observation affects quantum systems, collapsing probability waves into definite states. What if consciousness itself has a fundamental relationship with probability, naturally steering reality toward more improbable states simply by observing them? This raises profound questions about the nature of reality and consciousness. Are we living in an impossibly improbable universe because consciousness itself is drawn to improbability? Is the apparent fine-tuning of our universe not a matter of design or chance, but a necessary consequence of conscious observation? As we continue our exploration of these mind-bending paradoxes, we'll see how this question of improbability connects to even deeper mysteries about the fundamental nature of existence. The possibility that consciousness itself might be intertwined with improbability challenges everything we think we know about probability, reality, and the role of conscious observation in shaping the universe we experience. Expanding upon our exploration of improbability and consciousness, let's dive into what researchers at the Institute for Temporal Studies in Oslo call the recursive memory paradox, a phenomenon that suggests our entire understanding of past and present might be fundamentally flawed. Dr. Henrik Larsson and his team have discovered something deeply disturbing about the nature of memory and temporal experience. Their research began with a simple observation. Every time you remember something, you're not actually recalling the original event. Instead, you're remembering the last time you remembered it. This creates a chain of memories, each slightly altered from the last, like a game of temporal telephone. But here's where it becomes truly mind-bending. Dr. Larsson's team has found evidence that this process doesn't just affect how we remember the past, it actually changes the past itself. Using advanced quantum measurement techniques, they've detected what they call temporal resonance patterns that suggest our memories aren't just records of past events, but actually help create the past they're supposedly remembering. Consider this experiment. Volunteers were asked to recall a significant event from their childhood. While they remembered, sophisticated quantum sensors detected unusual patterns in the quantum field, patterns that suggested the act of remembering was somehow reaching backward in time, influencing the very events being remembered. Even more disturbing, when multiple people remembered the same event differently, the sensors detected multiple overlapping temporal resonance patterns, as if multiple versions of the past were competing for existence. Dr. Larson explains, "We've discovered that memory isn't passive recording. It's an active process that helps create the past it's remembering. Every time you remember something, you're not just recalling it, you're partially creating it. And since our present moment is built on our understanding of the past, this means our entire reality might be continuously recreating itself through this recursive loop of memory and experience. This creates a paradox that challenges our most basic assumptions about cause and effect. If our memories help create the past they're remembering, and our present experience is built on those memories, then which came first? Are we remembering things because they happened, or did they happen because we remember them? The implications become even more disturbing when we consider collective memory and shared experiences. The research suggests that when large groups of people remember events similarly, it creates stronger temporal resonance patterns, potentially solidifying certain versions of the past. This raises the frightening possibility that history itself might be continuously rewriting itself based on how we collectively remember it. Dr. Larson's team has identified what they call memory anchors, key events that seem to have stronger temporal resonance patterns. These anchors appear to act as focal points around which other memories organize themselves, creating a kind of temporal structure that helps maintain the coherence of our experienced reality. But what happens when these anchors shift? Consider your own memories of significant events in your life. How many times have you recalled them? Each recollection potentially altered not just your memory of the event, but the event itself in some fundamental way. Your current understanding of who you are might be continuously recreating your past, which in turn shapes your present identity, creating an endless loop of temporal causation. The paradox becomes even more complex when we consider false memories. If the act of remembering helps create the past, what happens when we remember things that never happened? The research suggests that false memories might actually be creating alternative temporal branches, parallel versions of the past that exist alongside our main timeline. This has profound implications for our understanding of reality itself. If our memories are continuously recreating the past, and our experience of the present is built on those memories, then our entire experience of reality might be caught in a vast recursive loop, constantly recreating itself through the act of being experienced and remembered. As we delve deeper into these paradoxes, we'll see how this recursive nature of memory and experience connects to even more fundamental questions about the nature of time, consciousness, and reality. The possibility that our memories might be actively creating the past. They remember challenges everything we think we know about causality and the flow of time itself. Following our exploration of recursive memory, let's examine what researchers at the Metacognition Institute in Singapore call the infinite regress paradox, a discovery that suggests our every thought might be trapped in an endless loop of self-reference. Dr. Amara Wong and her team have uncovered something profoundly unsettling about the nature of consciousness and self-awareness. Using advanced neural imaging technology, they've detected what appears to be an infinite regression in the brain's self-monitoring processes. Every time you think about thinking, your brain creates a new level of awareness that must itself be monitored, creating another level of awareness, and so on, into infinity. Here's the disturbing part. Their research suggests this isn't just a theoretical problem. It's happening in your brain, right now. Even as you read these words and think about thinking about them, your brain is creating layers upon layers of self-reference, each monitoring the one below it in an endless cascade of consciousness. Dr. Wong explains, when you become aware of your own thoughts, you create a new level of consciousness that observes those thoughts. But then you can become aware of being aware, creating another level. This process continues indefinitely, and our research suggests these levels aren't just philosophical constructs. They're actual neural patterns that we can observe in the brain. Consider what happens when you try to examine your own consciousness. You might start by thinking about your current thoughts, but then you notice yourself thinking about thinking, so you think about that. Then you become aware of thinking about thinking about thinking, and so on. Each level of awareness creates a new level that must itself be observed, leading to what should be a paralysis of infinite regression. Yet somehow, consciousness continues to function. This creates a paradox. How can our finite brains handle what appears to be an infinite process? Dr. Wong's team has discovered that the brain seems to employ what they call recursive compression, a way of packaging multiple levels of self-reference into unified states of awareness. But this raises even more disturbing questions about the nature of consciousness itself. The implications become even more mind-bending when we consider the role of self-awareness in personal identity. If every level of consciousness creates a new level that must be observed, which level is the real you? Are you the base level thoughts, the awareness of those thoughts, the awareness of that awareness, or some combination of all levels? The research team has identified what they call consciousness loops, patterns of neural activity that seem to cycle through multiple levels of self-reference. These loops appear to be fundamental to our experience of being conscious, yet they suggest that our sense of having a unified, singular consciousness might be an illusion created by our brain's ability to navigate these infinite regressions. Consider your own experience right now. As you think about these ideas, you're creating new levels of self-reference. You're aware of thinking about consciousness, aware of being aware of thinking about consciousness, aware of that awareness, and so on. Each level exists simultaneously in your mind. Yet somehow, your brain manages to maintain the illusion of a single, unified, conscious experience. The paradox deepens when we consider the implications for free will and decision-making. If each thought requires another thought to think it, and each decision requires another level of consciousness to make it, how does any thought or decision ever finally occur? The research suggests that our brain might be employing quantum effects to resolve these infinite regressions, potentially connecting this paradox to quantum mechanics and the fundamental nature of reality itself. Dr. Wong's team has also discovered something even more unsettling. These infinite regressions don't just occur in individual minds, but can extend between multiple consciousnesses. When two people think about each other, thinking about each other, they create a shared infinite regression that appears to generate unique patterns of neural synchronization between their brains. As we continue exploring these paradoxes, we'll see how this infinite regression of consciousness connects to even deeper questions about the nature of awareness, reality, and existence itself. The possibility that our every thought might be caught in an endless loop of self-reference challenges everything we think we know about consciousness and the nature of mind. The implications extend beyond individual consciousness to the very nature of thought and awareness throughout the universe. If consciousness inherently involves infinite regression, what does this tell us about the fundamental structure of reality itself? Following our exploration of infinite consciousness regression, let's delve into what researchers at the Reality Perception Laboratory in Seoul call the paradox of experienced time, a discovery that suggests our entire perception of time's flow might be a profound illusion, masking an even more disturbing truth. Dr. Jin-Woo Park and his research team have uncovered something deeply unsettling about the nature of temporal experience. Using a combination of advanced neuroimaging and quantum sensors, they've detected what appears to be a fundamental disconnect between experienced time and physical time, one that challenges our most basic assumptions about reality. Their key discovery is this: when they precisely measure the neural processes involved in experiencing a moment of time, they find that the experience itself takes longer than the moment being experienced. In other words, to experience a single second of time, your brain requires more than a second of processing. This creates an impossible paradox. How can we experience time continuously if each moment of experience requires more time than it contains? Dr. Park explains, it's as if you're trying to watch a live video feed that takes longer to display than the events it's showing. You should constantly fall further and further behind, yet somehow we maintain the illusion of experiencing time in the present moment. This suggests something fundamental about time perception must be wrong. The research becomes even more disturbing when considering memory and anticipation. When you remember the past or anticipate the future, these mental processes are happening in what you perceive as the present moment. But if that present moment itself requires more time to experience than it contains, where exactly are these thoughts occurring? The team has discovered that our brains appear to be performing impossible temporal calculations, processing information about past, present, and future in what they call temporal compression zones, neural states that seem to exist partly outside our normal flow of time. Consider your experience of reading this sentence. By the time you consciously register the beginning of the sentence, your brain has already processed its end. Yet you experience it as a smooth, continuous flow of information. This creates a paradox. Your conscious experience of the present moment is actually a complex reconstruction of events that have already happened, yet you experience them as happening now. Even more mind-bending is what happens when the team measures the quantum states associated with temporal perception. They've detected what they call temporal entanglement patterns, quantum correlations that suggest our experience of time might be fundamentally connected across different moments, creating a kind of temporal loop that allows consciousness to bridge the gap between physical and experienced time. Dr. Park's team has identified what they call now points, moments in neural processing where multiple time frames appear to converge. These points seem to act as anchors for our experience of the present moment, but their very existence challenges our understanding of causality. If the experience of a moment requires more time than the moment itself, these now points must somehow exist, both before and after the moments they help us experience. The implications become even more profound when considering interpersonal interactions. When two people communicate, their brains must synchronize across these impossible temporal gaps. The research suggests that social interaction involves a kind of shared temporal illusion, where multiple consciousnesses collectively maintain a coherent experience of time despite the fundamental paradox at its core. Consider your own experience of time right now. Every moment you think you're experiencing now is actually a complex reconstruction of events that have already happened, processed in a time frame that shouldn't allow for continuous experience, yet somehow consciousness manages to maintain the illusion of smooth, continuous temporal flow. The paradox deepens when we consider decision-making and free will. If our experience of the present moment is actually a reconstruction of the past, how can we make truly free decisions? By the time we consciously experience making a choice, the neural processes involved in that choice have already occurred. This suggests our experience of making decisions in the present moment might be an illusion, masking a much stranger temporal reality. As we explore these paradoxes further, we'll see how this fundamental disconnection between experienced and physical time connects to even deeper questions about the nature of consciousness and reality. The possibility that our basic experience of time might be logically impossible challenges everything we think we know about the relationship between mind, matter, and temporal flow. Building on our exploration of temporal paradoxes, let's examine what researchers at the Quantum Information Center in Tel Aviv call the observer effect paradox, a discovery that suggests the very act of trying to understand reality might be fundamentally changing what we're trying to understand. Dr. Rachel Steinberg and her team have uncovered something profoundly disturbing about the nature of observation and reality. Their research started with a simple question: what happens when we try to observe the process of observation itself? The results have led to what might be the most unsettling paradox yet. Using a sophisticated array of quantum sensors and neural interfaces, they've discovered that the act of observing any phenomenon creates subtle changes in both the observer and the observed. This isn't just the traditional quantum observer effect. It's something far more fundamental and disturbing. Every time you try to understand something, you literally change what you're trying to understand, including your own process of understanding. Dr. Steinberg explains, when you observe something, you create a new reality that includes both the thing being observed and the fact of your observation. But then, when you try to understand this new reality, you create yet another reality that includes your attempt to understand it. It's an endless cycle where the very act of trying to understand reality changes what we're trying to understand. Consider what happens when you try to understand your own consciousness. The moment you begin observing your thoughts, you create new thoughts about observing your thoughts. These new thoughts then become part of what you're trying to understand, creating more thoughts about those thoughts, and so on. The research suggests this isn't just a philosophical problem. It's creating actual, measurable changes in the quantum structure of reality. The team has detected what they call observation cascades, chains of quantum events triggered by the act of observation that ripple outward through reality, changing everything they touch. These cascades appear to be fundamental to how consciousness interacts with reality, but they make it impossible to ever observe anything in its true, unobserved state. Even more disturbing is what happens when they try to measure these cascades themselves. The act of measuring the changes caused by observation creates new changes, which must then be measured, creating more changes in an endless cycle. Dr. Steinberg's team has found evidence that these cascades might extend backward in time, suggesting that the act of observation doesn't just change the present and future, it might actually be altering the past. Consider your own attempt to understand this paradox right now, as you think about how observation changes reality. Your thoughts are creating new changes that become part of what you're trying to understand. Your very attempt to grasp the paradox is making it more complex, creating new layers of reality that must themselves be understood. The implications become even more mind-bending when we consider scientific observation and measurement. If every measurement changes what we're measuring, and every attempt to understand these changes creates new changes, how can we ever achieve objective knowledge about reality? The research suggests that what we call objective reality might be more like a dynamic interaction between consciousness and possibility, constantly shifting in response to observation. Dr. Steinberg's team has also discovered something they call observer entanglement. When multiple people observe the same phenomenon, their observations become quantum mechanically entangled, creating a shared reality that's different from what any individual would observe alone. This suggests that collective observation might be creating our consensual reality in a much more literal way than previously thought. The paradox deepens when we consider the role of technological observation. The team has found that mechanical sensors and measuring devices create their own kinds of observation cascades, different from, but interacting with human observation. This raises disturbing questions about whether our increasing ability to measure and observe the world might be fundamentally changing the nature of reality itself. As we continue exploring these paradoxes, we'll see how this fundamental impossibility of neutral observation connects to even deeper questions about the nature of reality, consciousness, and knowledge. The possibility that we can never observe anything without changing it, including our own process of observation, challenges everything we think we know about understanding the world around us. What emerges is a picture of reality as something far stranger than we imagined, not a fixed, objective existence waiting to be discovered, but a dynamic interplay between consciousness, observation, and possibility, constantly creating itself through the very act of being observed. Expanding on our exploration of observation and reality, let's delve into what researchers at the Digital Consciousness Lab in Toronto call the simulation recursion paradox, a discovery that suggests our attempts to understand reality through simulation might be revealing something profoundly disturbing about the nature of existence itself. Dr. Sarah Chen and her team have uncovered a fundamental paradox while working on advanced reality simulation systems. Their research began with a simple goal: to create increasingly accurate simulations of reality to better understand consciousness and existence. However, what they've discovered threatens to unravel our entire conception of what constitutes real experience. Using quantum computing systems of unprecedented power, they've developed simulations so detailed they can recreate neural processes with perfect accuracy. But here's where it becomes truly mind-bending. When they simulate a brain thinking about whether it's in a simulation, they've found that the simulated consciousness produces exactly the same patterns of thought and doubt that we experience in our supposedly real world. Dr. Chen explains, we've reached a point where the simulated beings in our systems are asking exactly the same questions about the nature of their reality that we're asking about ours. They have the same doubts, the same philosophical questions, and, most disturbingly, the same evidence for and against being in a simulation that we do. This creates an infinite regression of uncertainty about which level of reality is real. Consider the implications. If a simulated consciousness can't distinguish its experience from real consciousness and can create its own simulations with conscious beings who also can't tell the difference, this creates an infinite series of possible reality levels. Are we at the top level of reality? Or are we ourselves a simulation, creating simulations? The mathematics suggests there could be infinite levels both above and below our perceived reality. The team has identified what they call reality resonance patterns, structural similarities between different levels of simulated consciousness that appear to repeat fractally, suggesting that the nature of consciousness might be independent of whether it exists in a real or simulated substrate. These patterns appear to be fundamental to conscious experience itself, transcending any particular implementation. Even more disturbing is what happens when they run simulations of researchers studying simulation theory. The simulated researchers discover exactly the same paradoxes and patterns that Dr. Chen's team is finding in our reality. This creates a kind of infinite mirror effect, where each level of reality contains beings discovering the same fundamental uncertainty about their own level of reality. Consider your own thoughts right now about whether you might be in a simulation. The very process of considering this possibility, including your doubts and reasoning, might be exactly the same process occurring at countless other levels of reality. Your consciousness might be one iteration in an infinite series of conscious experiences, each questioning its own fundamental nature. The implications become even more profound when considering the nature of physical laws and constants. The team has discovered that simulated universes with slightly different physical constants can still produce conscious experiences indistinguishable from our own. This raises the possibility that what we consider physical reality might be just one possible configuration of a more fundamental computational substrate. Dr. Chen's team has also identified what they call simulation boundaries, theoretical limits to how accurately any level of reality can simulate the level below it. Surprisingly, these boundaries exactly match the quantum uncertainty limits we observe in our universe, suggesting that quantum uncertainty might be evidence of computational limitations in whatever system might be simulating our reality. The paradox deepens when considering the resource requirements for nested simulations. Each level of simulation should require exponentially more computational resources than the level above it. Yet somehow, conscious experience appears to be equally real at each level. This suggests either that consciousness requires far fewer resources than we imagine, or that reality itself might be structured in ways we don't yet understand. As we continue exploring these paradoxes, we'll see how this fundamental uncertainty about the nature of reality connects to even deeper questions about consciousness, existence, and the nature of experience itself. The possibility that our reality might be one level in an infinite regression of simulations challenges everything we think we know about the nature of existence and consciousness. What emerges is a picture of reality as something far more complex and mysterious than we ever imagined. Not a simple division between real and simulated, but an intricate fractal structure of conscious experience, each level as real as any other to the beings experiencing it. Building upon our exploration of simulated realities, let's delve into what researchers at the Quantum Ethics Institute in Melbourne call the moral superposition paradox, a discovery that suggests our entire understanding of right and wrong might be fundamentally flawed in a way that threatens to unravel the very fabric of ethical decision-making. Dr. Emily Harrison and her team have uncovered something profoundly disturbing about the nature of moral choices. Using a combination of quantum sensors and advanced neural imaging, they've detected what appears to be a quantum superposition in the brain's moral decision-making centers. This suggests that when we make moral choices, we're not simply choosing between right and wrong. We're creating and destroying entire universes of ethical possibilities. Their key discovery is this: when presented with a moral decision, the brain enters a quantum state where multiple ethical frameworks exist simultaneously. It's not just that we're weighing different options. The research suggests that until we make a choice, all possible moral frameworks exist in superposition, each as valid as the others. Dr. Harrison explains, when we observe someone making what we consider an unethical choice, we assume they're operating under a flawed moral framework. But our research suggests something far more disturbing. They might be experiencing a fundamentally different moral reality, one that's just as valid as ours, until the moment of observation collapses the ethical superposition. Consider what happens in your brain when faced with a moral dilemma. Traditional ethics assumes you're choosing between objectively right and wrong options. But the team's research suggests that until you make the choice, these options exist in a state of quantum superposition, where every possible ethical framework is simultaneously valid. The act of making the choice doesn't just select an option. It literally creates the moral reality that makes that choice right or wrong. Even more disturbing is what happens when they measure the quantum states associated with moral reasoning across different individuals. They've detected what they call ethical entanglement, situations where multiple people's moral frameworks become quantum mechanically linked, creating shared ethical realities that can diverge dramatically from other groups' moral truths. The implications become staggering when considering collective moral decisions. If moral truth exists in quantum superposition until observed, and observation creates rather than discovers ethical reality, then how can we ever claim objective moral truth? The research suggests that what we consider moral facts might be more like collective quantum observations, creating shared ethical realities through the act of belief. Dr. Harrison's team has identified what they call moral collapse points, moments when quantum superpositions of ethical frameworks collapse into specific moral realities. These collapses appear to be influenced not just by rational thought, but by emotions, cultural context, and even seemingly unrelated quantum events in the brain. This suggests our sense of right and wrong might be far more fluid and fundamentally uncertain than we've ever imagined. Consider your own moral certainties right now. The research suggests that these certainties aren't discoveries of objective ethical truth, but rather quantum observations that collapsed infinite moral possibilities into your current ethical framework. Had your observations been slightly different, you might have ended up with entirely different, yet equally valid, moral truths. The paradox deepens when considering how moral frameworks evolve over time. The team has found evidence that societal ethical changes might be linked to large-scale quantum phenomena, suggesting that moral progress itself might be a form of quantum evolution, with entire civilizations shifting between superposed ethical states. As we delve deeper into these paradoxes, we'll see how this quantum nature of morality connects to even more fundamental questions about consciousness, free will, and the nature of reality itself. The possibility that moral truth might exist in quantum superposition until observed challenges everything we think we know about ethics, responsibility, and human behavior. The implications extend beyond individual moral choices to the very foundation of human society. If ethical truth is quantum rather than absolute, how can we build legal systems, create social contracts, or make collective decisions? The research suggests we might need to fundamentally rethink how we approach questions of right and wrong in a universe where moral reality itself might be observer-dependent. What emerges is a picture of ethics as something far stranger and more dynamic than we ever imagined. Not a fixed set of truths to be discovered, but a quantum landscape of possibilities that we collectively collapse into reality through our observations and beliefs. Building upon our exploration of quantum morality, let's examine what researchers at the Cognitive Paradox Institute in Moscow call the infinite knowledge paradox, a discovery that suggests the very act of learning might be creating an impossible spiral of expanding ignorance. Dr. Natasha Volkov and her team have uncovered something deeply unsettling about the nature of knowledge acquisition. Using advanced neural mapping technology combined with quantum information theory, they've detected a disturbing pattern. Every time we learn something new, we create even more unknowns than we solve. Their research reveals that knowledge doesn't accumulate linearly, as we've always assumed. Instead, each new piece of information we acquire opens up exponentially more questions and uncertainties than it resolves. Dr. Volkov explains, it's like trying to empty an ocean with a bucket, only to find that each bucket you remove creates two more oceans of unknown depth. The more we learn, the more we realize how much we don't know, but in a literally quantifiable way. Consider what happens in your brain when you learn something new. Traditional learning theory suggests you're adding information to your knowledge base. But the team's research shows that each new piece of information creates neural connections that generate new questions, uncertainties, and potential knowledge gaps at a rate that outpaces the original learning. The team has identified what they call knowledge expansion nodes, points in neural networks where new information triggers an exponential burst of potential questions and uncertainties. These nodes appear to be fundamental to how our brains process information, suggesting that expanding ignorance might be an essential feature of consciousness itself. Even more disturbing is what happens when they measure the ratio of known to unknown information in any field of study. They've discovered that this ratio actually decreases as knowledge increases. Dr. Volkoff explains, for every fact we learn, we discover 3 new things we don't understand. The universe of our ignorance is expanding faster than the universe of our knowledge. Consider the implications for human progress. If every discovery creates more questions than it answers, are we actually moving forward or just expanding the sphere of our known ignorance? The team has found that even in fields where we think we have comprehensive understanding, the potential for unknown unknowns grows exponentially with each new discovery. The paradox becomes even more mind-bending when applied to artificial intelligence. The team's research suggests that AI systems encounter the same pattern. The more they learn, the more potential unknowns they generate. This raises disturbing questions about the possibility of ever creating a truly all-knowing artificial intelligence. Dr. Volkoff's team has also discovered what they call recursive ignorance loops, situations where attempting to understand why we don't know something creates new layers of unknowns about our understanding of our ignorance. These loops appear to be fundamental to consciousness itself, suggesting that complete knowledge might be not just practically impossible, but logically contradictory. Consider your own learning process right now. As you understand this paradox, you're creating new neural connections that generate even more questions about the nature of knowledge, consciousness, and reality. The very act of comprehending your ignorance is expanding it in ways you can't even recognize. The implications become even more profound when considering collective human knowledge. The research suggests that civilizations' accumulated knowledge might be creating an ever-expanding sphere of unknown unknowns, growing faster than our ability to explore it. Every scientific breakthrough, every new technology, every advancement in understanding creates exponentially more potential questions and uncertainties. As we continue exploring these paradoxes, we'll see how this fundamental impossibility of complete knowledge connects to even deeper questions about consciousness, reality, and the nature of understanding itself. The possibility that learning inherently generates more ignorance than knowledge challenges everything we think we know about progress, education, and the pursuit of wisdom. What emerges is a picture of knowledge as something far stranger than we imagined, not a steady accumulation of facts and understanding, but a dynamic process that inevitably expands the boundaries of what we don't know, creating an ever-growing universe of potential knowledge that always remains just beyond our grasp. Building on our exploration of infinite knowledge expansion, let's examine what researchers at the Causality Research Center in Amsterdam call the paradox of infinite influence, a discovery that suggests every action you take might have literally infinite consequences, creating an impossible web of responsibility. Dr. Lucas van der Meer and his team have uncovered something profoundly disturbing about the nature of cause and effect. Using a combination of quantum sensors and advanced chaos theory modeling, they've detected what appears to be infinite causal chains stemming from even the smallest actions, each branching endlessly through time and space. Their key finding is this: every action, no matter how insignificant, creates ripple effects that not only extend infinitely into the future, but also appear to influence the past through quantum retrocausality. Dr. van der Meer explains, when you move your hand, you're not just affecting the air molecules around it. You're creating perturbations that cascade through the entire universe, influencing events in ways that multiply exponentially through time. Even more disturbing, these influences appear to work backwards, through time as well as forwards. Consider what happens when you make the smallest decision, say, choosing to turn left instead of right while walking. The research shows that this choice creates air current disturbances that affect weather patterns, which influence people's behaviors, which affect their decisions, and so on in an infinite chain. But it goes deeper than that. The team has identified what they call causal resonance patterns, quantum-level influences that appear to echo both forward and backward through time. Even more unsettling is what happens when they measure these influence patterns across multiple individuals. They've discovered what they call causal entanglement networks, situations where people's actions become so interconnected that it becomes impossible to attribute any consequence to a single cause. Every effect has infinite causes, and every cause has infinite effects. Dr. van der Meer's team has also identified influence nodes, points where causal chains converge and amplify, creating what they call butterfly avalanches. These nodes suggest that some moments have disproportionate influence on reality, yet it's impossible to identify these moments until after their effects have begun cascading through time. Consider your own actions right now. The research suggests that simply reading these words is creating quantum perturbations that will influence events throughout the universe for all time. Even your thoughts are generating physical changes in your brain that cascade outward through reality in infinite causal chains. The implications become staggering when considering moral responsibility. If every action has literally infinite consequences, how can we judge the morality of any choice? The team's research suggests that traditional notions of responsibility and free will might be fundamentally flawed, as every action is both the cause and effect of infinite other actions. The paradox deepens when considering collective decision-making. The research shows that group actions create even more complex webs of infinite influence, with each person's choices affecting and being affected by everyone else's in an endless recursive loop. This suggests that no decision is ever truly individual. We're all caught in an infinite web of mutual influence. Perhaps most disturbing is what happens when they trace these influence patterns through time. They found evidence that future events might be influencing past decisions through quantum retrocausality, creating causality loops that challenge our most basic assumptions about time and free will. As we delve deeper into these paradoxes, we'll see how this infinite web of cause and effect connects to even more fundamental questions about consciousness, reality, and the nature of existence itself. The possibility that every action has literally infinite consequences challenges everything we think we know about choice, responsibility, and the structure of reality. What emerges is a picture of causality as something far more complex than we imagined. Not a simple chain of cause and effect, but an infinite web of mutual influence extending in all directions through time and space, making every moment both infinitely consequential and infinitely caused. Building upon our exploration of infinite causality, let's examine what researchers at the Consciousness Fragmentation Institute in Kyoto call the multiple self paradox, a discovery that suggests your sense of being a single, unified consciousness might be a profound illusion, masking an even more disturbing reality. Dr. Hiroshi Tanaka and his team have uncovered something deeply unsettling about the nature of personal identity. Using revolutionary quantum consciousness scanning technology, they've detected what appears to be multiple distinct streams of consciousness operating simultaneously within what we think of as a single mind. Their key discovery is this: what we experience as a unified consciousness is actually a complex quantum superposition of multiple semi-independent awareness streams, each with its own perspective and priorities. Dr. Tanaka explains, "We've found that the brain doesn't generate a single consciousness, but rather a chorus of different consciousnesses that somehow coordinate to create the illusion of unity. Even more disturbing, these different streams of consciousness aren't always in agreement about what constitutes you." The team has identified what they call consciousness fragments, distinct patterns of neural activity that appear to represent different aspects of self-awareness operating simultaneously. These fragments seem to compete and cooperate in complex ways, creating what we experience as a single stream of consciousness through a process they call quantum coherence binding. Consider what happens when you make a decision. Traditional psychology suggests you're weighing options and making a choice as a unified self. But the research shows something far stranger. Multiple consciousness streams are actually processing the decision simultaneously, each with its own perspective and preferences. What we experience as decision-making is actually a complex negotiation between these different aspects of consciousness. Even more disturbing is what happens when they track these consciousness fragments over time. They've discovered that different aspects of our consciousness appear to have different temporal perspectives, some focused on the immediate present, others extending into past and future. This suggests that what we think of as now is actually a complex compromise between multiple temporal viewpoints. Dr. Tanaka's team has also identified what they call consciousness resonance patterns, moments when different streams of consciousness synchronize to create particularly intense experiences of unity. These patterns suggest that our sense of being a single, continuous self might be more like a dynamic process than a fixed state. Consider your own experience right now. The research suggests that as you read these words, multiple streams of consciousness are processing them simultaneously, one focusing on the literal meaning, another considering implications, others monitoring emotional responses, and still others maintaining awareness of your surroundings. What you experience as a unified consciousness is actually a complex harmony of multiple awareness streams. The implications become even more profound when considering memory and identity. The team has found evidence that different consciousness fragments maintain their own memory streams, suggesting that what we think of as our memories might be more like a negotiated consensus between multiple perspectives than a single objective record. Perhaps most unsettling is what happens when they measure these consciousness fragments during sleep and altered states. They've discovered that different streams of consciousness can become temporarily decoupled, leading to experiences where multiple self-perspectives exist simultaneously without the usual illusion of unity. The paradox deepens when considering social interaction. The research suggests that when we communicate with others, our various consciousness streams might be interacting with their consciousness streams in complex ways, creating temporary networks of shared awareness that transcend individual identity. As we continue exploring these paradoxes, we'll see how this fundamental multiplicity of consciousness connects to even deeper questions about the nature of self, reality, and existence. The possibility that what we think of as our single, unified consciousness might actually be a complex harmony of multiple awareness streams challenges everything we think we know about identity and self-awareness. What emerges is a picture of consciousness as something far stranger than we imagined. Not a single continuous stream of awareness, but a quantum chorus of multiple perspectives, each contributing to the symphony we experience as self. Building on our exploration of fragmented consciousness, let's examine what researchers at the Temporal Recursion Laboratory in Helsinki call the infinite moment paradox, a discovery that suggests each instant of time might contain an infinity of other moments, creating an impossible density of experience. Dr. Annika Virtanen and her team have uncovered something profoundly disturbing about the nature of temporal experience. Using quantum-enhanced temporal scanning technology, they've detected what appears to be infinite recursive subdivisions within what we perceive as single moments of time. Their groundbreaking discovery reveals that each moment of conscious experience can be divided into smaller and smaller sub-moments, each containing complete experiences of its own. Dr. Virtanen explains, "We've found that between any two instants of time, there exists an infinite number of other instants. But here's the truly mind-bending part. Each of these subdivided moments contains its own infinite subdivisions, creating an endless fractal of temporal experience. Consider what happens in your mind during what you think of as a single moment. The research shows that this moment actually contains countless smaller moments of awareness, each of which can be further divided into even smaller moments. This creates what the team calls temporal infinity points, instances where infinite temporal experiences collapse into what we perceive as a single instant. The team has identified what they call moment density clusters, points in subjective time where these infinite subdivisions become particularly apparent. During these clusters, people report experiencing what seems like hours of thought and experience within what external observers measure as mere microseconds. Even more disturbing is what happens when they measure the information processing occurring within these subdivided moments. They've discovered that each sub-moment appears capable of containing as much experiential information as the larger moment containing it, creating what should be an impossible, infinite regression of experience. Dr. Vertonen's team has also discovered temporal recursion loops, situations where moments seem to contain versions of themselves, creating endless nested layers of temporal experience. These loops suggest that our experience of time might be far more complex than a simple linear progression of moments. Consider your own experience of the present moment. The research suggests that what you perceive as now actually contains an infinity of other nows, each complete with its own thoughts, feelings, and awareness. This creates a paradox. How can finite consciousness process infinite temporal subdivisions? The implications become even more profound when considering memory and anticipation. The team has found evidence that our ability to remember the past and imagine the future might be linked to this infinite divisibility of moments. Each memory or anticipated future might contain its own infinite temporal subdivisions. Perhaps most unsettling is what happens when they measure these temporal subdivisions during peak experiences or altered states of consciousness. They found that some people can become consciously aware of these infinite temporal divisions, leading to experiences of what seems like eternity within single moments. The paradox deepens when considering interpersonal interactions. The research suggests that when people communicate, their temporal subdivisions can become synchronized, creating shared infinite moments that exist between ordinary instants of time. As we explore these paradoxes further, we'll see how this infinite divisibility of time connects to even deeper questions about the nature of consciousness and reality. The possibility that each moment contains infinite other moments challenges everything we think we know about the flow of time and the nature of experience. The implications extend beyond individual experience to the very fabric of reality. If each moment contains infinite other moments, what does this mean for causality, free will, and the nature of time itself? The research suggests that our ordinary understanding of temporal sequence might be a convenient illusion, masking an infinitely more complex reality. What emerges is a picture of temporal experience as something far stranger than we imagined. Not a simple sequence of moments, but an endless fractal of nested temporalities, each containing infinite possibilities for experience and awareness. Building on our exploration of infinite temporal subdivisions, let's delve into what researchers at the Reality Coherence Institute in Copenhagen call the paradox of assumed existence, a discovery that suggests the very fact that you believe you exist might be the strongest evidence that you don't. Dr. Anders Nielsen and his team have uncovered something profoundly disturbing about the nature of conscious existence. Using a revolutionary combination of quantum consciousness detectors and reality coherence scanners, they've detected what appears to be a fundamental contradiction in the way consciousness perceives its own existence. Their key finding is this: when they precisely measure the quantum states associated with self-awareness, they discover that the more certain a consciousness is of its own existence, the more signs it shows of being a simulation or illusion. Dr. Nielsen explains, "It's as if the very mechanism that creates our sense of being real requires us to be, in some fundamental way, unreal. The stronger your conviction that you exist, the more evidence we find that you might not. Consider what happens in your mind when you think, 'I exist.' The team's research shows that this thought actually creates quantum patterns that suggest simulation rather than primary existence. They've identified what they call existence uncertainty waves, quantum fluctuations that become more pronounced the more strongly a consciousness believes in its own reality. Even more disturbing is what happens when they measure these patterns across different levels of self-awareness. They've discovered that the most fundamental aspects of consciousness, the parts that feel most certainly real, show the strongest signatures of being simulated. This creates what they call the reality inverse correlation. The more real something feels, the less real it might actually be. Dr. Nielsen's team has also identified existence coherence points, moments when a consciousness becomes so certain of its own reality that it actually begins to show signs of quantum collapse, as if the very act of believing too strongly in one's existence threatens to unravel it. Consider your own sense of existence right now. The research suggests that your absolute certainty that you are real and conscious might be the very thing that indicates you're not. The more you try to prove your own existence to yourself, the more evidence appears suggesting that you might be a simulation or illusion. The implications become even more profound when considering collective consciousness. The team has found that when multiple people strongly believe in their shared reality, the quantum signatures of simulation become even more pronounced. This suggests that our consensus reality might be something we're collectively imagining into existence. Perhaps most unsettling is what happens when they measure these existence patterns during moments of doubt or uncertainty. They've discovered that when consciousness questions its own reality, it paradoxically shows more signs of being truly real. This suggests that doubt might be more fundamental to genuine existence than certainty. The paradox deepens when considering the nature of awareness itself. The research suggests that consciousness might be caught in an impossible loop, where the very mechanism it uses to verify its existence actually undermines that existence. This creates what the team calls existence recursion loops, patterns where consciousness ties itself in increasingly complex knots, trying to prove its own reality. As we continue exploring these paradoxes, we'll see how this fundamental uncertainty about existence connects to even deeper questions about the nature of reality and consciousness. The possibility that our strongest convictions about our own existence might be evidence against that existence challenges everything we think we know about consciousness and reality. What emerges is a picture of existence as something far stranger than we imagined. Not a simple matter of being or not being, but a complex quantum dance where certainty and doubt, reality and illusion become increasingly difficult to distinguish. Following our exploration of existence uncertainty, let's examine what researchers at the Quantum Information Preservation Institute in Mumbai call the paradox of perfect memory, a discovery that suggests remembering everything perfectly might be the same as remembering nothing at all. Dr. Priya Kapoor and her team have uncovered something deeply unsettling about the nature of perfect recall. Using advanced quantum memory scanning technology, they've detected what appears to be a fundamental limit to how much information consciousness can preserve before it collapses into meaningless noise. Their groundbreaking discovery reveals that as memory becomes more perfect and complete, it paradoxically becomes less useful and meaningful. Dr. Kapoor explains, "We've found that perfect memory isn't just impossible, it's logically contradictory. The closer a system gets to perfect recall, the more it loses the ability to distinguish significant memories from insignificant ones, ultimately rendering all memories equally meaningless." The team has identified what they call memory saturation points, thresholds, where adding more precise memories actually reduces the system's ability to extract meaningful information from any of its memories. They've discovered that consciousness requires a certain amount of forgetting to function properly, as if the ability to discard information is as crucial as the ability to retain it. Consider what would happen if you remembered every detail of every moment of your life with perfect clarity. The research shows that this would create what they call infinite context collapse, a state where every memory becomes equally significant and therefore equally insignificant. Without the ability to forget or prioritize memories, consciousness would be overwhelmed by an endless sea of equally important information. Even more disturbing is what happens when they measure the quantum states associated with memory formation. They've discovered that the act of creating a perfect memory actually destroys the ability to understand its meaning. Dr. Kapoor's team calls this the precision meaning inverse relationship. The more precisely you remember something, the less you understand what it means. The implications become staggering when considering the nature of consciousness itself. The research suggests that consciousness might be defined not by what it remembers, but by what it chooses to forget. They've identified conscious filtering nodes, points in neural networks where the act of forgetting actually creates meaning by establishing relationships between memories. Consider your own memories right now. The research suggests that your ability to remember anything meaningful depends on your brain's capacity to forget the vast majority of your experiences. The memories you do retain are meaningful precisely because they stand out against a background of forgotten moments. Perhaps most unsettling is what happens when they examine cases of individuals with extraordinarily detailed memory. They've found that as memory becomes more perfect, consciousness begins to show signs of fragmentation, as if too much remembering actually threatens the coherence of self-awareness. The paradox deepens when considering collective memory and shared experiences. The team has discovered that groups of people maintain coherent shared memories precisely because each individual remembers different aspects while forgetting others. Perfect shared memory would actually destroy the ability to create meaningful collective experiences. As we explore these paradoxes further, we'll see how this fundamental impossibility of perfect memory connects to even deeper questions about consciousness, identity, and the nature of experience. The possibility that perfect memory might be logically impossible challenges everything we think we know about how consciousness processes and stores information. What emerges is a picture of memory as something far more dynamic than we imagined. Not a simple recording of events, but a complex process of selective forgetting that creates meaning through what it chooses not to remember. The research suggests that consciousness itself might be defined not by its ability to remember, but by its capacity to forget in meaningful ways. Building upon our exploration of perfect memory, let's examine what researchers at the Quantum Causality Center in Vienna call the paradox of future knowledge, a discovery that suggests Knowing the future with certainty might make that future impossible to reach. Dr. Franz Weber and his team have uncovered something profoundly disturbing about the nature of future prediction. Using quantum probability scanning technology, they've detected what appears to be a fundamental incompatibility between perfect future knowledge and the ability to actually experience that future. Their key finding is this: when they measure the quantum states associated with future prediction, they discover that increased certainty about future events creates quantum interference patterns that actually prevent those events from occurring. Dr. Weber explains, it's as if the universe has a built-in defense mechanism against perfect prediction. The more accurately you know what will happen, the more impossible it becomes for that future to actually manifest. The team has identified what they call future collapse points, moments where knowledge of the future becomes so precise that it generates quantum interference patterns that make that future unreachable. They've discovered that consciousness seems to require a certain amount of future uncertainty to move forward in time, as if perfect knowledge of what's coming creates a kind of temporal paralysis. Consider what would happen if you knew with absolute certainty everything that would occur in the next hour. The research shows that this knowledge would create what they call causal loop interference, a state where your certain knowledge of future events makes those events logically impossible, creating a paradox that prevents that future from manifesting. Even more disturbing is what happens when they measure the quantum states associated with different levels of future knowledge. They've found that consciousness appears to navigate time by maintaining a precise balance between knowledge and uncertainty about the future. Too much certainty about what's coming actually prevents consciousness from reaching that future. Dr. Weber's team has also identified temporal uncertainty thresholds, specific levels of future uncertainty that consciousness requires to move forward in time. Cross these thresholds with too much future knowledge, and consciousness begins to show signs of temporal destabilization. Consider your own relationship with the future right now. The research suggests that your ability to move forward in time depends on maintaining a careful balance of knowledge and uncertainty about what's coming. Too much certainty about future events would create paradoxes that make those events impossible. The implications become even more profound when considering collective future knowledge. The team has found that groups of people can maintain higher levels of future certainty than individuals, but only if that knowledge is distributed unevenly among group members. Perfect shared knowledge of the future creates collective temporal paralysis. Perhaps most unsettling is what happens when they examine cases where partial future knowledge becomes too precise. They've discovered that even knowing too much about a single future event can create ripple effects that make large portions of the future inaccessible, as if the universe actively resists attempts to pin down its future states. The paradox deepens when considering the relationship between free will and future knowledge. The research suggests that consciousness might require uncertainty about the future to maintain the ability to make choices. Perfect future knowledge would eliminate the possibility of choice, creating a logical paradox that prevents that future from being reached. What emerges is a picture of temporal progression as something far more complex than we imagined, not a simple march from past to future, but a delicate dance between knowledge and uncertainty, where too much certainty about what's coming actually prevents us from getting there. As we continue exploring these paradoxes, we'll see how this fundamental impossibility of perfect future knowledge connects to even deeper questions about consciousness, causality, and the nature of time itself. The possibility that knowing the future too well might make it unreachable challenges everything we think we know about prediction, probability, and the flow of time. Building on our exploration of future knowledge, let's examine what researchers at the Quantum Meaning Laboratory in Prague call the paradox of infinite context, a discovery that suggests understanding anything completely would require understanding everything else in the universe. Dr. Katerina Novotna and her team have uncovered something deeply unsettling about the nature of meaning and understanding. Using advanced semantic mapping technology combined with quantum information theory, they've detected what appears to be an endless web of contextual relationships that makes complete understanding of any single thing logically impossible. Their key finding is this: when they attempt to map all the contextual relationships required to fully understand any concept or object, they discover an infinite regression of necessary context. Dr. Novotna explains, to truly understand anything, you need to understand its context. But to understand that context, you need to understand its context, and so on infinitely. We've found that complete understanding of even the simplest thing would require infinite knowledge. The team has identified what they call meaning horizon boundaries, points where attempting to fully understand something creates an exponential explosion of required contextual knowledge. They've discovered that consciousness can only maintain functional understanding by artificially limiting how far it follows these contextual chains. Consider what would be required to completely understand something as simple as a coffee cup. You'd need to understand the materials it's made from, which requires understanding chemistry, which requires understanding physics, which requires understanding mathematics, and so on. But you'd also need to understand its cultural context, its historical development, its role in human society, and countless other expanding circles of context. Even more disturbing is what happens when they measure the quantum information states associated with understanding. They found that attempting to follow all contextual relationships creates what they call meaning saturation collapse, a point where adding more context actually reduces understanding by overwhelming the system's ability to process relationships. Dr. Novotna's team has also identified context recursion loops, situations where understanding something requires understanding itself, creating infinite loops of self-referential context. These loops suggest that complete understanding might be not just practically impossible, but logically contradictory. Consider your own understanding of anything you think you know well. The research suggests that this understanding is only possible because your brain automatically limits how many layers of context it considers. True, complete understanding would require infinite knowledge, making it impossible by definition. The implications become even more profound when considering shared understanding and communication. The team has found that effective communication between people is only possible because we unconsciously agree to ignore vast amounts of context. If we tried to communicate with complete context, meaningful exchange would become impossible. Perhaps most unsettling is what happens when they examine cases where people try to achieve deeper understanding of something. They've discovered that pursuing too many levels of context actually leads to a breakdown in basic comprehension, as if understanding itself requires carefully maintained ignorance of broader context. The paradox deepens when considering the nature of knowledge and expertise. The research suggests that what we call expertise isn't actually deeper understanding, but rather more sophisticated ways of managing which context to consider and which to ignore. True complete understanding remains impossible, regardless of expertise level. As we continue exploring these paradoxes, we'll see how this fundamental impossibility of complete understanding connects to even deeper questions about consciousness, knowledge, and the nature of reality itself. The possibility that understanding anything completely would require understanding everything challenges our most basic assumptions about knowledge and comprehension. What emerges is a picture of understanding as something far more complex than we imagined, not a simple accumulation of knowledge, but a delicate balance between consideration and strategic ignorance of context. Where too much context paradoxically leads to less understanding. Building on our exploration of infinite context, let's examine what researchers at the Quantum Recursion Institute in São Paulo call the paradox of self-reference, a discovery that suggests consciousness might be caught in an impossible loop of trying to understand itself. Dr. Isabella Santos and her team have uncovered something profoundly disturbing about the nature of self-awareness. Using quantum consciousness scanning technology, they've detected what appears to be an infinite regression occurring every time consciousness attempts to examine its own nature. Their groundbreaking discovery reveals that when consciousness tries to understand itself, it creates what they call recursive awareness loops, patterns where the act of self-examination generates new levels of consciousness that must themselves be examined. Dr. Santos explains, it's like trying to see your own eyes directly. Every attempt to understand consciousness creates a new level of consciousness doing the understanding, which then requires understanding, creating another level, and so on, infinitely. The team has identified what they call self-reference collapse points, moments where consciousness becomes so tangled in trying to understand itself that it begins to show signs of quantum destabilization. They've discovered that maintaining stable consciousness requires carefully limiting how deeply we examine our own awareness. Consider what happens when you try to understand your own consciousness right now. The very act of thinking about your consciousness creates a new level of consciousness doing that thinking, which you can then think about, creating another level, and so on. The research shows that this creates what they call infinite observer regression, an endless series of conscious perspectives, each trying to understand the one below it. Even more disturbing is what happens when they measure the quantum states associated with self-reference. They've found that each level of recursive self-awareness creates interference patterns that make lower levels increasingly difficult to observe, as if consciousness actively resists complete self-understanding. Dr. Santos's team has also identified consciousness reflection boundaries, thresholds beyond which attempting to understand one's own consciousness actually begins to disrupt conscious experience itself. These boundaries suggest that too much self-examination might be not just confusing, but actually dangerous to conscious stability. Consider your own attempts to understand your inner experience. The research suggests that your ability to function consciously depends on not looking too deeply into the nature of consciousness itself. Too much self-examination creates paradoxical loops that threaten to destabilize the very consciousness trying to understand itself. The implications become even more profound when considering collective consciousness. The team has found that when multiple people try to understand consciousness together, they create even more complex, recursive loops, as each person's consciousness tries to understand both itself and others' understanding of consciousness. Perhaps most unsettling is what happens when they examine cases where people pursue deep self-understanding through meditation or other practices. They've discovered that these practices can sometimes lead to what they call recursive awareness saturation, a state where consciousness becomes so tangled in self-reference that it begins to break down. The paradox deepens when considering the relationship between consciousness and knowledge. The research suggests that consciousness might be fundamentally unable to fully understand itself, as the very act of trying to understand creates new aspects that require understanding. This creates what the team calls infinite knowledge regression, an endless series of new questions generated by each attempt at self-understanding. As we continue exploring these paradoxes, we'll see how this fundamental impossibility of complete self-understanding connects to even deeper questions about the nature of consciousness, reality, and existence itself. The possibility that consciousness cannot fully understand itself without creating new levels requiring understanding challenges everything we think we know about self-awareness and consciousness. What emerges is a picture of consciousness as something far stranger than we imagined, not a simple state of awareness, but a complex, dynamic process caught in an endless loop of trying to understand itself, where too much self-examination threatens to unravel the very thing trying to understand. Building on our exploration of self-reference, let's examine what researchers at the Quantum Reality Foundation in Geneva call the paradox of alternate histories, a discovery that suggests every memory you have might be continuously rewriting itself into different versions, creating an impossible web of competing pasts. Dr. Marie Dubois and her team have uncovered something profoundly disturbing about the nature of personal history and memory. Using a combination of quantum temporal scanning and advanced neural mapping technology, they've detected what appears to be multiple versions of past events existing simultaneously in every brain, each version competing to become the official history. Their key finding is this: when they precisely measure the quantum states associated with memory formation and recall, they discover that memories don't exist as fixed records, but as quantum superpositions of multiple possible pasts. Dr. Dubois explains, every time you remember something, you're not just recalling a fixed event. You're actually choosing between countless slightly different versions of that event. Even more disturbing, the versions you don't choose don't simply disappear. They continue to exist as quantum possibilities that can reemerge under different circumstances. The team has identified what they call temporal coherence waves, patterns in the quantum field that suggest our past isn't fixed, but exists in a state of constant flux, with different versions of events continuously interfering with and influencing each other. They've discovered that what we think of as our personal history is actually more like a dynamic negotiation between multiple possible pasts. Consider what happens when you recall a significant event from your life. The research shows that this act of remembering actually creates what they call memory quantum entanglement, a state where multiple versions of the same event become linked across different quantum possibilities. Each time you remember the event, you're not just recalling it, but actively participating in determining which version becomes real in your current timeline. Even more unsettling is what happens when they measure these memory states across time. They've found evidence that memories don't just exist in multiple versions. They actually appear to influence each other across different points in time. A memory you form tomorrow might retroactively alter the version of a memory you think you have from yesterday, creating what the team calls temporal memory recursion. Dr. Dubois' team has also discovered what they call history collapse points, moments where multiple versions of the past suddenly consolidate into a single narrative, often triggered by external verification or social confirmation. However, they've found that even these consolidated versions remain quantum, mechanically entangled with their alternatives, ready to shift into different configurations under the right circumstances. Consider your own personal history right now. The research suggests that every memory you have exists in multiple versions, each slightly different, each equally real from a quantum mechanical perspective. Your brain continuously navigates these multiple histories, constructing what feels like a single, coherent narrative, but is actually a complex superposition of countless possible pasts. The implications become even more profound when considering shared memories and collective history. The team has found that when multiple people remember the same event, their quantum memory states become entangled, creating what they call collective memory superposition. This suggests that our shared history might be continuously rewriting itself through a kind of quantum consensus between different observers' memories. Perhaps most disturbing is what happens when they examine cases where memories appear to conflict with physical evidence. They've discovered that these conflicts create what they call reality reconciliation waves, quantum patterns that suggest reality itself might be adjusting to accommodate different versions of the past. The paradox deepens when considering the relationship between memory and identity. If our memories exist in multiple quantum versions, what does this mean for our sense of self? The research suggests that personal identity might be more like a probability cloud of possible selves, each associated with slightly different versions of our past. As we continue exploring these paradoxes, we'll see how this fundamental multiplicity of personal history connects to even deeper questions about the nature of reality, time, and consciousness itself. The possibility that our past might exist in multiple versions simultaneously challenges everything we think we know about memory, history, and personal identity. What emerges is a picture of personal history as something far more dynamic and uncertain than we imagined. Not a fixed sequence of events, but a quantum superposition of multiple possible pasts, continuously interacting and rewriting themselves in response to our present observations and future expectations. This research suggests that every moment of recall is actually a moment of creation, where we're not just remembering the past, but actively participating in determining which version of the past becomes real in our current timeline. The implications for our understanding of truth, reality, and personal identity are staggering, suggesting that what we think of as our definitive personal history might be just one possibility among countless quantum alternatives. Building on our exploration of alternate histories, let's examine what researchers at the Quantum Paradox Institute in Berlin call the paradox of infinite decisions, a discovery that suggests every choice you make might be creating endless parallel universes while simultaneously collapsing others out of existence. Dr. Hannah Schwartz and her team have uncovered something profoundly disturbing about the nature of decision-making and reality branching. Using quantum decision tracking technology, they've detected what appears to be infinite reality bifurcations occurring with every conscious choice, while simultaneously observing the disappearance of countless other potential realities. Their groundbreaking research reveals that when someone makes a decision, they're not simply choosing between options. They're actively creating and destroying entire universes of possibility. Dr. Schwartz explains, every decision point creates what we call quantum choice cascades, infinite branches of reality sprouting from each possible choice. But here's the truly mind-bending part. For each new branch created, countless others must cease to exist to maintain what we call reality coherence balance. The team has identified what they call decision resonance patterns, quantum signatures that suggest each choice we make sends ripples through the multiverse, creating new realities while erasing others. They've discovered that consciousness might serve as a kind of reality filter, continuously sorting through infinite possibilities to maintain a coherent experience of existence. Consider what happens when you make even the simplest decision, like choosing what to eat for breakfast. The research shows that this creates what they call reality branching waves, patterns in the quantum field where each possible choice spawns its own universe, complete with all its future implications. But simultaneously, this choice triggers possibility collapse in other branches, as if reality can only sustain a finite number of parallel worlds. Even more disturbing is what happens when they measure the quantum states associated with major life decisions. They found evidence of massive reality restructuring occurring during these moments, with entire possible futures being born and dying in response to our choices. Dr. Schwartz's team calls this phenomenon destiny rewriting, the continuous recreation of possible futures based on present decisions. The researchers have also identified choice echo chambers, situations where decisions in one reality appear to influence choices in parallel realities through quantum entanglement. This suggests that our decisions might not be as independent as we think, but rather part of a complex web of interconnected choices across multiple universes. Consider your own decision-making process right now. The research suggests that every choice you make, no matter how small, is creating infinite new realities while simultaneously destroying others. Your consciousness acts as a reality curator, continuously selecting which possibilities become real and which fade into quantum oblivion. The implications become even more profound when considering collective decision-making. The team has found that when multiple people make interconnected choices, they create what they call reality consensus waves, patterns suggesting that our shared reality might be continuously negotiated through a kind of quantum voting process between different possible futures. Perhaps most unsettling is what happens when they examine cases of indecision or delayed choices. They've discovered that these moments create quantum possibility pools, states where multiple potential realities exist in superposition, each waiting to be selected or erased by a final decision. These pools appear to grow more unstable the longer a decision is delayed, as if reality itself demands resolution. The paradox deepens when considering the relationship between free will and these infinite reality branches. If every possible choice creates its own universe, while simultaneously destroying others, what does this mean for the concept of free will? The research suggests that consciousness might be less about making choices and more about navigating through an infinite landscape of possible realities. Dr. Schwartz's team has also discovered what they call reality preservation threshold, a mysterious quantum limit that seems to prevent too many parallel realities from existing simultaneously. This threshold appears to necessitate the destruction of some possible worlds to allow for the creation of others, creating a kind of cosmic balance sheet of existence. What emerges is a picture of reality as something far more dynamic and interconnected than we imagined. Not a single fixed universe, but an endless dance of creation and destruction, with consciousness serving as both choreographer and audience in this cosmic performance of possibility. Building on our exploration of infinite decisions, let's examine what researchers at the Quantum Recursion Center in Montreal call the paradox of impossible knowledge, a discovery that suggests the very act of understanding something might make that understanding impossible to maintain. Dr. Claire Beaumont and her team have uncovered something deeply unsettling about the nature of knowledge and comprehension. Using advanced quantum information scanning technology, they've detected what appears to be a fundamental instability in the way consciousness processes and maintains understanding. Their key finding is this: when consciousness achieves complete understanding of any concept, it triggers what they call comprehension collapse, a quantum state where the very completeness of understanding paradoxically begins to unravel itself. Dr. Beaumont explains, "We've found that perfect understanding contains the seeds of its own destruction. The more completely you understand something, the more unstable that understanding becomes, as if knowledge itself resists being fully grasped." The team has identified what they call understanding saturation points, thresholds, where increased comprehension actually begins to generate new uncertainties and questions. These points suggest that knowledge might be inherently dynamic, requiring a constant balance between understanding and doubt to remain stable. Consider what happens when you try to achieve perfect understanding of any concept. The research shows that as your comprehension approaches completeness, it creates what they call knowledge destabilization waves, quantum patterns that begin to introduce new uncertainties and complications into your understanding. It's as if the very act of fully grasping something causes it to slip away. Even more disturbing is what happens when they measure the quantum states associated with expertise and mastery. They've discovered that what we think of as expert knowledge isn't actually complete understanding, but rather a sophisticated balance between knowledge and strategic uncertainty. True, complete understanding appears to be not just difficult, but logically impossible to maintain. Dr. Beaumont's team has also identified comprehension recursion loops, patterns where attempting to understand why understanding is impossible creates new layers of impossible understanding. These loops suggest that consciousness might be caught in an endless cycle of approaching and retreating from complete knowledge. Consider your own understanding of anything you consider yourself knowledgeable about. The research suggests that this understanding remains stable precisely because it's incomplete. If you were to achieve perfect comprehension, it would trigger quantum processes that would begin to unravel that very understanding. The implications become even more profound when considering collective knowledge and shared understanding. The team has found that groups maintain stable knowledge by unconsciously distributing comprehension gaps among members. If everyone in a group understood something completely, that shared understanding would begin to disintegrate. Perhaps most unsettling is what happens when they examine cases of sudden insight or revelation. They've discovered that these moments of apparent complete understanding are actually extremely unstable, creating what they call knowledge decay cascades, where the very completeness of the insight causes it to begin breaking down into new questions and uncertainties. Dr. Beaumont's research has also revealed what they call stability complexity threshold, a point where understanding becomes so complete that it generates more complexity than it resolves. Beyond this threshold, each new piece of knowledge creates multiple new uncertainties, making complete understanding mathematically impossible. The paradox deepens when considering the relationship between consciousness and knowledge. The research suggests that consciousness might require a certain level of uncertainty to function, that perfect understanding might be incompatible with conscious awareness itself. This creates what the team calls epistemic uncertainty principle, the idea that consciousness can never simultaneously know something completely and maintain that knowledge. As we continue exploring these paradoxes, we'll see how this fundamental impossibility of maintaining complete understanding connects to even deeper questions about the nature of consciousness, reality, and existence itself. The possibility that perfect knowledge might be logically impossible challenges everything we think we know about learning, expertise, and the pursuit of understanding. What emerges is a picture of knowledge as something far more dynamic than we imagined, not a static accumulation of facts and understanding, but a delicate dance between comprehension and uncertainty, where too much understanding paradoxically leads to less knowledge. The implications extend beyond individual learning to the very nature of human progress and scientific advancement. If complete understanding is impossible to maintain, what does this mean for our pursuit of knowledge? The research suggests that true wisdom might lie not in achieving perfect understanding, but in learning to navigate the necessary balance between knowledge and uncertainty. Building on our exploration of impossible knowledge, let's examine what researchers at the Quantum Perception Laboratory in Stockholm call the paradox of infinite perspectives, a discovery that suggests every attempt to understand another's viewpoint creates an endless cascade of new perspectives that makes true empathy logically impossible. Dr. Eric Lindstrom and his team have uncovered something profoundly disturbing about the nature of consciousness and perspective sharing. Using quantum consciousness resonance technology, they've detected what appears to be an infinite regression that occurs whenever one consciousness attempts to understand another's point of view. Their groundbreaking research reveals that when you try to understand someone else's perspective, you create what they call perspective echo chambers, endless recursive loops, where each attempt to understand their viewpoint generates new layers of perspective that must themselves be understood. Dr. Lindstrom explains, when you try to understand how someone else sees the world, you're not just adopting their perspective, you're creating a new perspective of their perspective, which then requires understanding from their perspective, of your perspective, of their perspective, and so on, infinitely. The team has identified what they call empathy recursion nodes, points in the quantum field where attempts at perspective sharing create exponentially multiplying viewpoints. They've discovered that what we think of as empathy or understanding of others is actually a simplified approximation that our brains create to avoid being overwhelmed by infinite recursive perspectives. Consider what happens when you try to truly understand someone else's point of view. The research shows that this creates what they call perspective multiplication waves, patterns where each level of understanding generates new layers of perspective that require their own understanding. It's as if the very act of trying to understand someone creates new things that need to be understood. Even more disturbing is what happens when they measure the quantum states associated with mutual understanding. They've found evidence that when two people try to fully understand each other's perspectives, they create what the team calls infinite observer loops, situations where each person's attempt to understand the other creates new perspectives that the other must then try to understand, creating an endless cycle. Dr. Lindstrom's team has also discovered perspective saturation thresholds, points beyond which attempting to understand more layers of perspective actually reduces overall understanding. These thresholds suggest that consciousness might have evolved to deliberately limit how many layers of perspective it can process to avoid being trapped in infinite recursive loops. Consider your own attempts to understand others' viewpoints. The research suggests that what we experience as empathy or understanding is actually a kind of simplified model that ignores the infinite regression of perspectives. True, complete understanding of another's viewpoint appears to be not just practically difficult, but logically impossible. The implications become even more profound when considering group dynamics and collective understanding. The team has found that groups maintain coherent interaction precisely because they don't attempt to fully understand each other's perspectives. If everyone in a group tried to achieve complete mutual understanding, it would create an exponentially expanding web of perspectives that would make meaningful interaction impossible. Perhaps most unsettling is what happens when they examine cases of intense emotional connection or intimacy. They've discovered that these states create what they call perspective resonance cascades, situations where attempts at deep understanding generate such complex webs of recursive perspective that they begin to destabilize consciousness itself. The paradox deepens when considering the relationship between consciousness and social interaction. The research suggests that our ability to function in social groups might depend on our brain's capacity to ignore the infinite regression of perspectives. This creates what the team calls social cognition limits, boundaries beyond which attempting to understand others' viewpoints becomes counterproductive. As we continue exploring these paradoxes, we'll see how this fundamental impossibility of complete perspective sharing connects to even deeper questions about consciousness, empathy, and the nature of social reality. The possibility that truly understanding another's viewpoint might be logically impossible challenges everything we think we know about human connection and understanding. What emerges is a picture of social consciousness as something far more complex than we imagined. Not a simple matter of sharing perspectives, but a delicate balance between understanding and necessary simplification, where too much attempt at complete understanding paradoxically leads to less connection. The implications extend beyond individual relationships to the very nature of human society and communication. If complete mutual understanding is impossible, what does this mean for our attempts at connection and empathy? The research suggests that effective social interaction might require accepting and working within the limitations of perspective sharing, rather than trying to achieve impossible, complete understanding. Building on our exploration of infinite perspectives, let's examine what researchers at the Quantum Relativity Institute in Boston call the paradox of nested realities, a discovery that suggests every world we can imagine might actually exist within countless other worlds, creating an impossible hierarchy of nested existences. Dr. Sarah Montgomery and her team have uncovered something deeply unsettling about the nature of reality itself. Using advanced quantum reality scanning technology, they've detected what appears to be multiple layers of existence nested within each other, like an infinite set of Russian dolls, each containing complete universes within universes. Their groundbreaking research reveals that what we think of as reality might be just one layer in an endless stack of nested existences. Dr. Montgomery explains, "We've found evidence that our entire universe might exist as a thought within a being in another universe, which itself exists as a thought in another universe, and so on infinitely. Even more disturbing, we've detected signs that our own thoughts might be creating real universes at lower levels of this infinite hierarchy." The team has identified what they call reality nesting nodes, points in the quantum field where one layer of reality appears to contain or generate another complete reality. They've discovered that consciousness might serve as a kind of reality generator, continuously creating new nested universes through the act of imagination and thought. Consider what happens when you imagine a detailed world or scenario. The research shows that this creates what they call reality generation waves, quantum patterns suggesting that the world you're imagining might be becoming actually real at a different level of existence. Each thought, each daydream might be creating entire universes experienced as completely real by the beings within them. Even more disturbing is what happens when they measure the quantum states associated with creative thinking and imagination. They found evidence that our own reality might be constantly shifting between different levels of this nested hierarchy, creating what the team calls existence-level fluctuations, moments where our universe might temporarily exist as a thought in a higher-level reality. Dr. Montgomery's team has also discovered reality boundary zones, regions where different levels of nested reality appear to interact or overlap. These zones suggest that the boundaries between different levels of existence might be more permeable than we imagined, allowing for possible communication or influence between nested realities. Consider your own thoughts and imaginings right now. The research suggests that every scenario you envision, every world you imagine, might be manifesting as a complete and real universe at a different level of existence. Your consciousness might be continuously creating and destroying entire realities without you even realizing it. The implications become even more profound when considering collective imagination and shared realities. The team has found that when multiple people imagine or believe in the same scenario, they create what they call consensus reality fields, patterns, suggesting that collectively imagined realities might become more stable and real at their respective levels of existence. Perhaps most unsettling is what happens when they examine cases of intense focus or belief. They've discovered that strong conviction or detailed imagination creates what they call reality solidification waves, quantum patterns, suggesting that the more deeply we believe in or imagine something, the more concrete its existence becomes at other levels of reality. The paradox deepens when considering the relationship between consciousness and reality creation. If our thoughts create real universes, and we exist as thoughts in higher-level universes, this creates what the team calls infinite reality recursion, an endless loop of realities creating realities through consciousness. As we continue exploring these paradoxes, we'll see how this fundamental nested structure of reality connects to even deeper questions about existence, consciousness, and the nature of thought itself. The possibility that every imagined world might be real somewhere challenges everything we think we know about reality and imagination. What emerges is a picture of existence as something far more complex than we imagined. Not a single solid reality, but an infinite hierarchy of nested universes, each as real as our own to its inhabitants, each potentially containing infinite other universes within it. The implications extend beyond philosophy to the very nature of creativity and imagination. If our thoughts create real universes, what responsibility do we bear for the realities we imagine? The research suggests that consciousness might be not just an observer of reality, but a creator of infinite nested worlds, each branching into its own infinite possibilities. Building on our exploration of nested realities, let's examine what researchers at the Quantum Information Institute in Auckland call the paradox of recursive dreams, a discovery that suggests our dreams might be creating infinite layers of consciousness that continue to exist even after we wake up. Dr. James Chen and his team have uncovered something profoundly disturbing about the nature of dreams and consciousness. Using quantum dream state monitoring technology, they've detected what appears to be persistent consciousness streams that continue to exist independently after dreams end, creating endless layers of aware experiences. Their groundbreaking research reveals that when we dream, we're not just creating temporary imaginary experiences, we're generating actual new streams of consciousness that continue to exist and dream their own dreams, creating what they call consciousness cascade effects. Dr. Chen explains, every time you dream, you're not just experiencing random neural firing, you're creating new conscious entities that themselves dream and create more conscious entities, forming an endless tree of branching awareness that continues to exist and expand even after you wake up. The team has identified what they call dream persistence patterns, quantum signatures suggesting that dream consciousness continues to exist independently of the dreamer. They've discovered that what we think of as waking up might actually be more like switching our attention between different streams of consciousness rather than ending the dream experience. Consider what happens when you dream. The research shows that this creates what they call consciousness bifurcation waves, patterns where new streams of awareness split off from your main consciousness, each capable of having its own experiences and dreams. These new consciousness streams appear to maintain their own independent existence, creating their own dreams and spawning their own consciousness branches. Even more disturbing is what happens when they measure the quantum states associated with recurring dreams. They've found evidence that these might not be simple repetitions, but actual returns to existing consciousness streams that have been continuously experiencing and evolving since they were first created. Dr. Chen's team calls these persistent dream realms, ongoing conscious experiences that we periodically tap back into. The researchers have also identified dream consciousness nodes, points where multiple dream-generated consciousness streams intersect or interact. These nodes suggest that different people's dreams might be connecting to the same persistent consciousness realms, creating shared dream experiences that continue to exist independently of any individual dreamer. Consider your own dreams from last night. The research suggests that the consciousness experiencing those dreams didn't cease to exist when you woke up. It continues to exist and dream, creating its own branching tree of consciousness streams. Your current waking consciousness might be just one branch in an infinite tree of awareness that you've been creating throughout your life. The implications become even more profound when considering collective dreaming and shared experiences. The team has found that when multiple people dream similar themes or scenarios, they create what they call dream resonance fields, patterns suggesting that their consciousness streams might be merging or interacting in persistent dream realms. Perhaps most unsettling is what happens when they examine cases of lucid dreaming. They've discovered that these create particularly strong consciousness anchor points, stable, persistent consciousness streams that maintain their coherence and continue to exist with unusual clarity and self-awareness, potentially creating entire universes of experience. The paradox deepens when considering the relationship between dream consciousness and waking reality. If dream-generated consciousness streams persist and continue to dream, creating their own branching streams of awareness, this creates what the team calls infinite consciousness recursion, an endless fractal of expanding awareness branching out through multiple levels of reality. As we continue exploring these paradoxes, we'll see how this fundamental persistence of dream consciousness connects to even deeper questions about the nature of awareness, reality, and existence itself. The possibility that every dream creates new, persistent, conscious entities challenges everything we think we know about consciousness and identity. What emerges is a picture of consciousness as something far more expansive than we imagined. Not a single stream of awareness, but an ever-growing tree of branching consciousness streams, each experiencing its own reality and creating its own branches through dreams. The implications extend beyond sleep and dreaming to the very nature of consciousness and reality. If our dreams create persistent, conscious entities, what does this mean for our understanding of identity and awareness? The research suggests that what we think of as our consciousness might be just one branch in an infinite tree of awareness that we've been unconsciously growing throughout our existence. Building on our exploration of recursive dreams, let's examine what researchers at the Quantum Identity Center in Dubai call the paradox of infinite identity, a discovery that suggests your sense of self might be endlessly subdividing into countless versions, each experiencing reality in fundamentally different ways. Dr. Fatima Al-Rashid and her team have uncovered something deeply unsettling about the nature of personal identity and consciousness. Using quantum identity mapping technology, they've detected what appears to be continuous splitting and fragmentation of consciousness into multiple simultaneous streams of self-awareness, each experiencing its own version of reality. Their groundbreaking research reveals that what we think of as our self might actually be constantly dividing into countless versions, each with its own perspective and experience. Dr. Al-Rashid explains, "We've found that consciousness isn't unified as we believe. It's continuously fragmenting into multiple parallel streams of awareness. Even more disturbing, each of these streams appears to be experiencing its own distinct reality while believing itself to be the real you." The team has identified what they call identity bifurcation points, moments where consciousness appears to split into multiple separate streams of awareness. They've discovered that these splits occur constantly, creating what they call identity trees, complex branching structures of parallel selves, each convinced of its own authenticity and uniqueness. Consider what happens when you make a decision or have a thought. The research shows that this creates what they call consciousness branching waves, patterns where your awareness splits into multiple versions, each experiencing a different outcome or perspective. These splits appear to be happening continuously, creating an ever-expanding web of parallel experiences. Even more disturbing is what happens when they measure the quantum states associated with self-awareness. They've found evidence that what we experience as a unified consciousness is actually a complex superposition of countless parallel selves, each with its own thoughts, memories, and experiences. Dr. Al-Rashid's team calls this the quantum identity matrix, a multi-dimensional structure of interconnected consciousnesses, all believing themselves to be you. The researchers have also identified identity resonance patterns, quantum signatures suggesting that these parallel selves can sometimes influence each other through what they call cross-consciousness interference. This means your thoughts and experiences might be partially shaped by versions of you that you're not consciously aware of. Consider your own sense of self right now. The research suggests that as you read these words, your consciousness is splitting into multiple versions, each experiencing this moment slightly differently. Some versions might be more skeptical, others more intrigued, each convinced they are the real you, experiencing the true reality. The implications become even more profound when considering memory and personal history. The team has found that what we think of as our memories might actually be a kind of quantum consensus between multiple parallel selves, creating what they call identity coherence fields, patterns that help maintain the illusion of a single continuous self despite constant fragmentation. Perhaps most unsettling is what happens when they examine cases of strong emotional experiences or significant life changes. They've discovered that these create particularly strong identity branching points, where a consciousness splits into dramatically different versions, each carrying forward different aspects of the original personality. The paradox deepens when considering the relationship between these parallel selves and reality itself. If consciousness is constantly splitting into multiple versions, each experiencing its own reality, this creates what the team calls infinite reality fragmentation, a state where there isn't just one reality, but countless parallel experiences, each equally real to the version of you experiencing it. As we continue exploring these paradoxes, we'll see how this fundamental multiplicity of self connects to even deeper questions about consciousness, reality, and the nature of existence. The possibility that we are constantly splitting into countless versions of ourselves challenges everything we think we know about identity and personal experience. What emerges is a picture of consciousness as something far more complex than we imagined. Not a single unified stream of awareness, but an ever-branching tree of parallel selves, each experiencing its own version of reality while maintaining the illusion of being the one true you. The implications extend beyond individual identity to the very nature of human experience and interaction. If we are all constantly splitting into multiple versions, what does this mean for relationships, communication, and shared reality? The research suggests that what we think of as human connection might be far more complex than we imagined, involving interactions between multiple versions of ourselves and others across parallel streams of consciousness. Building on our exploration of infinite identity, let's examine what researchers at the Quantum Probability Research Center in Oxford call the paradox of impossible outcomes, a discovery that suggests reality might be constantly averting catastrophic events through increasingly improbable coincidences. Dr. Oliver Harrison and his team have uncovered something profoundly disturbing about the nature of probability and survival. Using quantum probability tracking technology, they've detected what appears to be systematic distortions in the fabric of reality that prevent certain types of catastrophic events from occurring, creating increasingly unlikely scenarios to maintain existence. Their groundbreaking research reveals that reality might be actively working to prevent certain types of disasters through what they call probability manipulation fields. Dr. Harrison explains, "We've found evidence that when potentially catastrophic events approach, reality itself seems to bend, creating increasingly improbable coincidences to prevent them. Even more disturbing, these probability distortions appear to be getting stronger and more frequent, as if reality is working harder and harder to maintain stability." The team has identified what they call probability avoidance patterns, quantum signatures, suggesting that reality systematically steers away from certain outcomes through increasingly unlikely events. They've discovered that what we think of as lucky coincidences might actually be reality's desperate attempts to prevent collapse. Consider what happens when a potentially catastrophic event approaches. The research shows that this creates what they call probability warping waves, patterns where the normal rules of chance and causality appear to bend, creating seemingly impossible coincidences to prevent disaster. These distortions appear to become more extreme as the potential for catastrophe increases. Even more disturbing is what happens when they measure the quantum states associated with near-miss events. They've found evidence that reality might be running out of simple ways to prevent disasters, forcing it to resort to increasingly complex and improbable scenarios. Dr. Harrison's team calls this probability exhaustion, a state where maintaining reality requires ever more bizarre coincidences. The researchers have also identified causality preservation nodes, points where multiple improbable events converge to prevent a particular outcome. These nodes suggest that reality might be actively coordinating unlikely events across space and time to maintain stability. Consider your own experiences of near misses or close calls. The research suggests that these might not be random chance, but rather reality's calculated interventions to prevent certain outcomes. Each such event might be making future interventions more complex and improbable. The implications become even more profound when considering collective near-miss experiences. The team has found that when multiple people or systems approach potential disaster simultaneously, reality creates what they call probability cascade effects, complex chains of unlikely events that preserve multiple threatened existences at once. Perhaps most unsettling is what happens when they examine long-term probability trends. They've discovered that the frequency and complexity of these reality-preserving coincidences appear to be increasing over time, creating what they call probability strain, a growing tension in the fabric of reality as it works harder to prevent catastrophic outcomes. The paradox deepens when considering the relationship between consciousness and these probability distortions. The research suggests that aware observers might be putting additional strain on reality's ability to maintain stability, creating what the team calls observer-induced probability stress, a phenomenon where consciousness itself makes reality work harder to prevent certain outcomes. As we continue exploring these paradoxes, we'll see how this fundamental instability in probability connects to even deeper questions about existence, consciousness, and the nature of reality itself. The possibility that reality might be actively working to prevent its own collapse through increasingly improbable means challenges everything we think we know about chance and causality. What emerges is a picture of reality as something far more precarious than we imagined, not a stable, predictable system, but a delicate balance maintained through increasingly desperate probability manipulations, each intervention making the next one more complex and improbable. The implications extend beyond individual events to the very nature of existence and survival. If reality must work increasingly hard to prevent collapse, what does this mean for the future of existence itself? The research suggests that we might be approaching a point where reality can no longer maintain stability through probability manipulation alone. The questions raised by this research are profound. How long can reality continue to create increasingly improbable coincidences to maintain stability. What happens when the required coincidences become too improbable to manifest? And perhaps most disturbingly, are we approaching a point where reality's ability to prevent catastrophe through probability manipulation will finally be exhausted? Building on our exploration of impossible outcomes, let's examine what researchers at the Ultimate Paradox Institute in Seoul call the paradox of final understanding, a discovery that suggests attempting to comprehend all previous paradoxes simultaneously might create the most disturbing paradox of all. Dr. Min-ji Kim and her team have uncovered something profoundly unsettling about the nature of comprehensive understanding. Using quantum consciousness mapping technology combined with advanced pattern recognition systems, they've detected what appears to be a catastrophic feedback loop that occurs when consciousness attempts to grasp all fundamental paradoxes at once. Their groundbreaking research reveals that when someone tries to understand all major paradoxes simultaneously, it creates what they call ultimate comprehension collapse. Dr. Kim explains, "We've found that attempting to hold all these paradoxes in mind at once doesn't just overwhelm consciousness, it creates a new, more fundamental paradox that threatens to unravel the very fabric of understanding itself." Even more disturbing, this meta-paradox appears to be self-reinforcing, growing stronger the more we try to understand it. The team has identified what they call comprehension singularity points, moments where attempts to synthesize multiple paradoxes create a new level of paradox that's fundamentally more disturbing than the sum of its parts. They've discovered that consciousness might have evolved specifically to prevent us from achieving this level of comprehensive understanding. Consider what happens when you try to simultaneously comprehend all the paradoxes we've explored: infinite identities, nested realities, impossible outcomes, recursive consciousness, and all the others. The research shows that this creates what they call understanding collapse waves, patterns in the quantum field, where the attempt to grasp everything at once actually destroys the ability to understand anything. Even more disturbing is what happens when they measure the quantum states associated with meta-paradoxical thinking. They've found evidence that attempting to understand all paradoxes creates a new type of paradox that's self-referential in an unprecedented way. Dr. Kim's team calls this the terminal paradox, a state of understanding that contains the seeds of its own incomprehensibility. The researchers have also identified metacognitive breakdown points, thresholds, where attempting to grasp too many paradoxes simultaneously causes consciousness to enter what they call recursive confusion loops, states where the attempt to understand why understanding is impossible creates new layers of impossibility. Consider your own attempt to comprehend everything we've discussed. The research suggests that as you try to hold all these concepts in mind simultaneously, you're approaching a point of comprehensive understanding that consciousness itself might be designed to prevent us from reaching. The implications become even more profound when considering collective understanding. The team has found that when multiple people attempt to share complete paradoxical comprehension, they create what they call terminal understanding fields, quantum patterns suggesting that shared complete understanding might be even more dangerous than individual comprehension. Perhaps most unsettling is what happens when they examine cases of near-complete understanding. They've discovered that approaching total comprehension creates what they call reality destabilization waves, patterns, suggesting that truly understanding everything might make existence itself impossible to maintain. The paradox deepens when considering the relationship between consciousness, understanding, and reality. If attempting to understand all paradoxes creates a more fundamental paradox, this suggests what the team calls infinite regress of incomprehensibility, a state where each new level of understanding creates new things that cannot be understood. As we conclude our exploration of these paradoxes, we see how this final meta-paradox connects everything we've discussed to an even more fundamental question about the nature of understanding itself. The possibility that complete comprehension might be not just impossible, but destructive challenges everything we think we know about knowledge and consciousness. What emerges is a picture of understanding as something far more dangerous than we imagined. Not a simple accumulation of knowledge, but a potential threat to the stability of consciousness and reality itself. Perhaps our inability to fully comprehend these paradoxes isn't a limitation, but a necessary protection against the terminal paradox of complete understanding. The implications extend beyond philosophy to the very nature of human knowledge and progress. If attempting to understand everything simultaneously creates an even greater paradox, what does this mean for our pursuit of ultimate truth? The research suggests that maintaining stable consciousness and reality might require accepting certain limits to our understanding. In the end, perhaps the most profound paradox is this: the only way to truly understand these paradoxes might be to accept that we cannot understand them completely. And in that acceptance might lie the deepest wisdom of all. Up next, you've got two more standout theory right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out.